Alright, here we have the RC low-pass filter. V of T is applied here. I watch that on the oscilloscope as well as the filtered version on the oscilloscope right here. Signal again is applied on this side of the resistor. Monitor the input and output side of the filter on the scope. Wanted to point out on the capacitor that it's an electrolytic. You need to make sure you get the correct polarity. So mine indicates negative polarity that I've connected to ground. Let's fire up the arbitrary waveform generator, and I'll start the waveform editor. I'm going to set up a decreasing set of step voltages for the test waveform. I'll select kilohertz units, and I need 50 kilosamples per second. I want to have a total of 5 segments. I need each segment to be 2 milliseconds in duration. And I think you get the idea. So I finish that off for the rest of the segments. We have a total duration then of 10 milliseconds. You'll notice that there's a wide variety of signal forms that you can select. I'll pick DC level. And for this test signal, I want to start it out at 10 volts. For the next segment, put that 2 volts down at 8 volts. And so on until we get to 2 volts, I believe. Now you need to save this using 2 different file formats. The default format is the one that's necessary for the arbitrary waveform generator. But if you want to have the opportunity to edit this source waveform again, you need to make sure you save that in the editor waveform format as well. So I've just created that on the desktop. Now I'll go ahead and save that as the waveform file. Confirm that that's correct, 50 kilohertz for the sample rate. And I'll give it the same base file name. Alright, I'll go ahead now and load that file from the desktop into the arbitrary waveform generator, enable it, and don't forget this, the update rate is not included as part of the data file, so we need to specify that ourselves, 50 kilohertz. And again, confirm that the time axis is correct. 0.01 seconds is a 10 millisecond period. Alright, I'll show the filtered output on channel 1, so that's going to look like the blue trace. And the green trace is the original decreasing stair-step waveform. Go ahead and use edge triggering to stabilize the display. And you notice the average value is just that constant signal being picked out by the low-pass filter. We can then read the effective DC value of the waveform right here. And then on channel 1, that would be the average value of our waveform.